Welcome back to Lucid Science. This week, we'll be looking at a paper by Hopewell et al. Investigating plastic recycling, challenges and opportunities, published in 2009. First, let's define some terms. Recycling is the action or process of using recovered material to manufacture a new or similar product. This applies especially to plastics, as they're incredibly reusable if done correctly. Downgrading is the process of reusing recovered plastics for a lower tier use, such as piping and structural materials. Post-consumer plastic has completed its life cycle as a consumer item, like a plastic bottle, that would otherwise be disposed of if not recycled. Lastly, polymer is the moldable molecular material that makes plastic. Okay, I think we're ready, so let's get into it. There are substantial benefits that have come with the invention of plastics, in terms of durability and cost. However, these benefits have come at the detriment of the environment. Today, plastics are almost entirely derived from oils produced from fossil fuels. In fact, about 4% of annual petroleum collection becomes the plastics that we use every day. In addition, another 4% of petroleum goes into the production of plastics, making plastics take up 8% of annual fossil fuel collection. 50% of plastics produced are used for a single use, like packaging and disposable consumer items like straws and utensils. 25% for infrastructure such as piping and structural materials, and the remainder for consumer uses such as electronic goods and furniture. This can be seen in Table 1, where packaging and building construction make up 61% of plastic uses. But packaging alone contributes to 58% of waste, and this is the root of the problem with the current recycling system. Due to the recent invention of plastic only 60 years ago, its true longevity is not yet known. However, the majority of polymers manufactured today will last for at least decades, if not millennia. From this point of view, the advantages of reusing and recycling are obvious. Recycling is a waste management strategy, but it also contributes to restoring ecological balance, because in a natural system, there is no waste, only products that can be reused. Overall waste can be reduced through the classic 4R strategy, in order of most to least effective. Reduce, reuse, recycle, and recover, with landfills as the least desirable management strategy. Next, let's go through current waste management strategies to determine their environmental benefits and downfalls. For disposing of waste, landfills fall at the bottom of this list. They provide incredible short-term waste management by allocating all waste to one area and burying it, but the long-term consequences outweigh this convenience. This is the worst strategy because recyclable products go straight from production to waste without being repurposed in any way. Incineration is a less prevalent strategy. Within this system, trash is burned in order to recover energy stored in its materials, but this can have significant consequences for air quality. It is also a poor strategy because products immediately become waste, but has one benefit in obtaining energy. For proactive strategies, downgauging and reuse are the best. Downgauging attempts to reduce the amount of packaging used per item, to reduce waste overall. This is a great method that needs to be implemented more in the future. Reuse is also important and needs to be done more. 40 years ago, reuse of post-consumer packaging like glass milk bottles was really common. But we shifted away from this strategy and need to find ways to implement reuse into our everyday lives again. Okay, let's talk about recycling. The fundamental problem with the current recycling strategy is with post-consumer plastics, like straws, plastic bags, and containers for food. In fact, the volumes of post-consumer waste are up to 5 times higher. Let's talk about the reasons why post-consumer waste is so abundant. First is the limits of the current recycling facilities. Most local authorities or material recovery facilities don't collect flexible consumer packaging because of deficiencies in the equipment used to recycle plastic materials. These materials can be anything from labels on plastic bottles, to plastic flexible containers that produce is often sold in, to bubble wrap. Second is cost. Historically, the primary methods of waste disposal have been by landfill or incineration. As a result, recycling has required significant subsidies because of the low cost of oil compared to the high cost of recycling materials. However, these restrictions are changing as technology improves and the economic benefits of recycling are being realized. First, one of the key benefits of recycling is to reduce the need to produce more plastic. Additionally, there are greater environmental benefits for mechanical recycling over landfill and incineration. As a consequence, the value of recycled polymer and the viability of recycling has dramatically increased as of late. Figure 3 shows this shift as mechanical recycling, seen in black, has dramatically increased, and this trend has only grown since 2003. Okay, let's wrap it all up. Recycling is the most valuable strategy for waste management of plastic products. It makes increasing sense both economically and environmentally, but still faces significant challenges that can be overcome if done correctly. And that's why recycling of a wider range of plastic packaging and post-consumer goods, along with incentives to reuse plastic rather than manufacturing new material, must happen. We are not going to get rid of plastics entirely, so we must first and foremost reduce our use of plastic if we hope to care for the health of the environment. And when you do use it, try to use it more than once in order to reduce the amount of plastic going into the recycling stream in the first place. Find us on social media at Conservation Made Simple, and I'll see you in 2 weeks for more Lucid Science.